Thank you, Shreya. Good morning to all of you. Let us start today's class. It is 9 o'clock. Most of the students, they have already attending now. Just try to recall the pin numbers. We have already discussed the pin numbers of a 305 timer. And first pin, just try to recall in your mind. I will show you the one by one. Ground, pin number 1, pin number 2 is a trigger, pin number 3 is a rewind in your just recall from your memory. Third is a output, fourth is a reset, and 5 is a control voltage, 6 is a threshold, 7 is a discharge, and 8 is a plus VCC. So this pin note we have already discussed, and try to just remember these pin numbers and the description, so that it will help when you are conducting any experiment, when you are doing hobby project, when you are making use of this particular IC. Now let me continue discussion. These are the pinouts. When we discuss in detail, you'll have to know. Now just a description I have given. Ground, normally connected to the circuit common ground. And remember, any ground, all of you know, whenever we are conducting an experiment with using an operational amplifier, all ground should be shorted. This is one point which you have to remember. And the trigger input to the lower comparator and is used to set the latch. How, in which circuit that we are going to discuss in detail with the circuit diagram. And output is a pin number 3, and the voltage is available at pin number 3, maximum whatever you have given the supply voltage. More than that you will never get it. Just take a 30 seconds to read this. After 30 seconds, I will go to the next pin numbers. Let me go to the next. Pin number 4. This pin is also used to reset the latch. In some books they say as a flip-flop latch. All of you know what is the major difference. Flip-flop needs a clock, latch doesn't need. The reset pin forces the output to go low irrespective of inputs to the flip-flop. Whatever may be the flip-flop input, but once if I make this active, automatically this will become high, output will go low. When it is not used, it is recommended that the reset input always tie to the plus VCC so that Q2 will not conduct, so that 305 timer will not reset. So observe this carefully. So this pin is also used to reset the latch and return the output to a low state. The reset pin forces the output to go low irrespective of input what you are giving to the flip-flop or a latch. And when it is not used, usually it is recommended to connect to the plus VCC. In most of the circuit, you observe Astable mode, Monostable mode, Astable application, Monostable application. Everywhere we connect this to the VCC so that it should not be reset. Observe this. So when I give this low, automatically this will become active and output will become low. So you have a few seconds, you can just go through. I will give the 30 seconds, try to understand. Control, this pins allows direct access to the 2/3 VCC. You can observe here, this is pin number 5, which is connected to the 2/3 VCC. And also indirectly, you can access this 1/3 VCC also. Because if you give any external voltage here, automatically it will impact on the 1/3 VCC as well as 2/3 VCC. So this is what I am talking to you people. So this you can take a 30 seconds and try to understand. Let us go to the next. Threshold. All of you know the threshold. Pin number 6. Pin number 6 is one input to the upper comparator and is used to reset the latch, which causes the output to go low. In most of the circuit, we are going to use this pin number 6 to reset the latch so that output will go to the low. So take a 30 seconds, read it, copy down. With circuit diagram, we will discuss all these pins again because operation you have to discuss. Let us go to the next. Discharge. So discharge, when the transistor is turned on, when this Q1 becomes on, pin number 7 is effectively short to the ground. You can say this will become a short circuited. In most of the experiment, we are going to use this particular pin number 7, and whenever this is high, and automatically this becomes a collector to emitter short circuited, and this pin number 7 is grounded. Take a 30 seconds, try to understand. Last pin number 8 plus VCC we apply. It is also referred to as a VCC and V plus. The positive supply voltage we are applying to this particular pin number 8. Now let us go to the next. This is schematic diagram. Internally a circuit diagram how it looks, but no need to remember, just I am showing for your reference. And this is a functional diagram. This I want you people to understand perfectly. See, read this. Threshold is greater than 2/3 VCC. When this is greater than 2/3 VCC, flip-flop is set. Why this becomes high? Flip-flop is set, and when this is high, output will become low. When this is low, this is high, transistor becomes on. Please observe carefully. If you understand these two slides, astable mode, monostable mode, all the application you can understand easily. Observe carefully. When threshold becomes greater than 2/3 VCC, this is set, flip-flop becomes this is high, and output becomes low. Transistor Q1 conducts. I repeat, observe this, when it is more compared to 2/3 VCC, this is set, flip-flop become high, output become low, flip-flop output is high, therefore Q1 conducts. I will give you 30 seconds, try to understand this. One important point I want you to remember, whenever this is high, this will be low. Whenever this is low, this is high. Output of this you will get, there is a knot. Please observe this carefully. Now let us go to the next slide. If you understand these two slides, a 355 timer you can understand very easily. Now, when trigger becomes less than 1/3 VCC, this is 1/3 VCC. When this becomes less than 1/3 VCC, this will become high. When this is high, this becomes low. When this is low, output becomes high. When this is high, when this is low, transistor will become off, or 7 to 1 open circuit. Observe carefully. Hey, see here. This becomes high, this becomes 0, output becomes high, and transistor becomes off. I want you people to observe carefully. When this becomes low, reset becomes high, this becomes low, and output becomes high, transistor off. I'll give 30 seconds, just try to understand again. It operates in two modes, 355 timer. One is a astable mode, another is a monostable mode. Note down, 355 timer operates in two modes. One is a astable mode, another is a monostable mode. The circuit, waveform, the working, we are going to discuss in this particular chapter one by one. We will take astable, then we will go to the monostable. A circuit, waveform, working, and some of the application we will try to discuss in this particular chapter. So let us go to the next. This is a astable circuit diagram. You can note down. Pin number 6 and 2 are shorted, given to the capacitor, and you have a resistor. R1, R2 I take sometimes. I may take R1, R2, RA, RB. No problem. Resistors only. 4 and 8. Always 4 is shorted with the 8. And pin number 3 is the output. Pin number 5 I can keep it open, or I can connect a capacitor to maintain that particular voltage without disturbing that voltage. Note on this, you have another 30 seconds. The waveform you note down, but how you are going to get this waveform, sir, at pin number 3 will definitely discuss. And if the time permits, derivation also will discuss. But waveform we will discuss. Let us go to the next slide. Anyway, circuit will be visible to you in the next slide also. Try to compare these two. The same connections, instead of RA, RB, I have taken R1 and R2. Pin number 2 and 6 are shorted. Here also 2 and 6 are shorted. And capacitor is connected. R1, R2. And this is connected to the VCC. This is the same connection I had done along with the internal block diagram. This is drawn by me only. And with considering the internal block diagram, we'll discuss the astable operation of a 555 timer. You should understand, anyway, the video will be available in the YouTube, and this all information will be available to you people, and you can understand easily. Now let me go to the next slide. We'll try to discuss the astable operation. Because hardly we may get another 5 to 6 classes, we have to finish this little bit early. Let us go to the operation. Try to understand. No need to note down. Understand this. Say timer output is high, flip-flop output is low, Q1 is off, C starts charging towards the VCC through R1 and R2. I am telling this is high, this is low, this is off. So therefore, I will wait for you people to read it and understand it. Till this. Say timer is high, whatever I am typed here, the same thing are coming one by one. So output of the flip-flop is low. When this is low, this will not conduct, this will become off. Hope these 3 lines are clear. जब ये high रहता है ये low रहता है, जब ये low रहता है ये high रहता है. This we have already discussed many times. Not is there. Now when this is low, this is off. When this is off, capacitor is not short circuited. Therefore now capacitor starts charging. Capacitor starts charging. Observe carefully through R1 and R2. Capacitor starts charging. Therefore, capacitor voltage is increasing and output is high. Try to understand the waveform also. I'll give you 1 minute. Try to understand this. If you want, you can copy down, or if you want to understand, just understand. Anyway, this all information will be available to you for revision later. I'll wait for another 30 seconds. I hope all of you understood this. Let me show you again if you want. So just read it. Timer output is high, flip-flop is low, Q1 is off, C starts charging towards VCC through R1 and R2. This is high, this is low. Now the C is charging towards VCC through the R1 and R2. And now let us continue. Say, now I am talking about when VC becomes greater than 2/3 VCC. When VC becomes greater than 2/3 VCC, observe this line. I am talking there is a connection. If this becomes more than 2/3 VCC, this will become high, this becomes high, this becomes low. When this is high, this transistor becomes on. And capacitor will start discharging. This only I am explaining, I am showing to you people. Try to understand. So when this is high, you see here, and this becomes low. And because this is high, transistor becomes on. Because of transistor becomes on, now capacitor got the path, it starts discharging. Capacitor will start discharging, therefore you will get a voltage drop in the capacitor, and now the output is low. You observe parallelly the waveforms also, circuit also, and I will give the 30 seconds. Try to understand. Let me repeat for your, just try to understand. Read it again. When VC becomes greater than 2/3 VCC, op amp 1 will become high, flip-flop becomes high, output becomes low, Q1 conducts, C start discharging through R2 and Q1. This is high, this is low, this is high, and Q1 becomes on. Therefore, the capacitors start discharging. Now, let me go to the next. When VC becomes less than 1/3 VCC, because it is discharging, the voltage will drop. Op amp 2 becomes high. Observe the color. Intentionally I am putting a different color here for your reference. When this becomes less than 1/3 VCC, op amp 2 will become a high. Therefore, when this becomes high, flip-flop output becomes 0. When this is 0, output becomes high. When output is high, when flip-flop is 0, transistor becomes off. Again, C starts charging towards the VCC through R1 and R2. This repeats continuously. Observe this carefully. So this is high because it has become less than 1/3 VCC. Because of that, this becomes low flip-flop output or latch output. Then this becomes high. Because it is a low, Q1 becomes off. Because Q1 becomes off, capacitor starts charging towards the VCC through R1 and R2. Again, when it crosses 2/3 VCC, flip-flop 1, op-amp 1 will give the high. Again, flip-flop becomes high. Timer becomes output low. This repeats. Take a minute or a few seconds to understand this. I'll wait for you people. I'll try to repeat for you people again. Try to understand. It's very simple. So I'm telling, when VC becomes less than 1/3 VCC, op-amp 2 will become high, flip-flop becomes 0, output becomes, timer output becomes high, Q1 will become off, C starts charging, this is high, and this becomes low, output becomes high, transistor becomes off, capacitor starts again charging. This will be repeated. When it again reaches about 2/3 VCC, op-amp 1 will give the output like that. This will be repeated. This is about a Astable multivibrator and Astable operation. This just now we have discussed all these things. Just you can take a minute to understand. This I have explained just now with the simulation, with the animation I have shown you. When VC becomes greater than 2/3 VCC, op-amp 1 will give the flip-flop. It's like a summary, and just go through this and take a 1 minute maximum if you want and try to understand. Somebody was asking, sir, I cannot do the lab. So is it impact? Is it going to impact? Definitely, when you won't do lab and you won't do simulation, you will not understand. So how to do in the home? Lot of simulators are there. Even I do to understand. This is available in microcap. I have done the simulation, and this after simulating I got this waveform. And usually this you cannot see in your lab. Think on that. Why? Only in the simulation you can see this. In the lab you cannot see this. I don't want to spend more time on this because we have to cover a little more portion. These are the applications we have: square wave generator, voltage controlled oscillator, FSK generator. With example, with the circuit diagram, we'll try to discuss in detail. Instead of just copying a square wave generator, voltage controlled oscillator, FSK generator, you try to understand how a square wave can be generated in this, because charging time period, discharging time period, equations are not same. So see, observe this. It's very easy. Just try to recall this circuit, what you have discussed. Charging is given by RB will come into picture whenever I say charging. Whenever discharging is there, it will discharge only through RB or R2 you can say. One resistor will come in the discharging, charging, two resistors will come into picture. But I want T1 equal to T2 so that I will get a square wave. Now, take 1 minute. If somebody want to answer for this, you can answer. How to get the square wave? So let me show how it can be done. Observe this, it's very simple. And let us consider the first T1 equal to 0.693 R1 into C. This is how I will get. See, capacitor is charging through this diode. Because this is 1.5K, this is a conducting means it's like a short circuit, so it prefers this particular path. So now only R1 will come into picture. So please try to understand, I am showing you. So only this will conduct, R2 will never come into picture. This is a charging. Similarly, discharging. So discharging is also, R2 will come into picture. So discharging, what will happen? Only through R2 it will discharge. So when it is discharging through R2 and it is charging through R1, if I make R1 equal to R2, automatically discharging time will become same. So this is for a square wave generation. And this is a way how we can generate a 50% duty cycle. Now FSK generation, how it can be done? So FSK generation, it is the same Astable only, but parallel with this R1, I am connecting a one transistor. For this I am giving you the say input high and low I am giving. So transistor conducts when Vin equal to high. When this is high, transistor will conduct. So NP, N it is, N, P. P if I give high, this will conduct. Whenever this conducts, this small resistor will come into picture. And this small resistor and this parallel combination value will be different. And when this doesn't conduct, only 4.7 K will come into picture. So therefore I will get a 2 timings. So I will get a 2 frequencies. Try to understand, I will show you. So when it conducts, this will become a lower resistance. But you will get a one particular resistor. If this is very small, automatically this will become if it is a potentiometer I have taken, very small resistor I have given. So now total resistance if I consider, it will become say Rx. And when transistor is off, so that time this resistor will never come into picture, only 4.7 K will come into picture. So that time the charging takes place through directly the 4.7. Say it's a Ry. So earlier it was a Rx, now it is a Ry. I got two different resistance. Therefore, I will get a two different frequency. Hence, I am saying it is a frequency shift keying. Two different frequencies I am going to get. Earlier, path was different, or I can say resistance was different because it was conducting. Now it is not conducting when it is low. Therefore, this particular path I will get. So two different resistance I will get when this is high, when this is low. Because of that, I am going to get two different frequencies. I will wait for you to understand this. Now this is about FSK generation. Now voltage controlled oscillate. What we do? Simply we give an input to the pin number 5. What will happen, sir? 2/3, 1/3 will change. When 2/3, 1/3 changes, automatically your frequency will change. The same thing we had discussed just now. Because of this frequency change, and speaker sound will also change. Based on the input voltage, we will get a speaker sound. This is a voltage controlled oscillator. You can connect to the CRO also. Observe that frequency or a waveform. And input you can give. Based on this voltage variation, 2/3, 1/3 will change. And because of that, you will find a frequency variation in the pin number 3. This is about a voltage controlled oscillator. You can, I will wait for another 10 to 15 seconds. You can try it. Material will be available to you people, but understand how it works. Material will get anywhere. There is not a problem nowadays. So let us go to the next. This is a monostable operation. So in the monostable operation, pin number 2 we are giving the trigger, and one resistor we are not connecting here. We are removing that, and pin number 2 we are connecting a trigger, and remaining 4 and 8 and other connections are same. Pin number 3 I am taking output. Just try to note down if you want circuit diagram, and with internal block diagram circuit I will show you. We will discuss using internal block diagram. In the exam usually they ask you to draw considering the internal block diagram of a 305 timer, explain either astable mode or monostable mode or some application. You should be able to do it. If you have any doubts, we'll have again one session for that doubt discussion only. If your representative ask, we'll schedule a separate Google Meet some other evening or some other afternoon. We'll discuss all your doubts, no problem. So let me go to the with block diagram. See, try to understand. Say, this is very important, try to understand. Say output is 0. I'm just observe, output is 0, flip-flop is set, Q1 is saturation, therefore V is equal to 0. Observe carefully. Now I am saying output is low and this is high, transistor is on, Vc is 0. Now I am discussing this is situation. Next, what I will do, observe carefully. Next step, I will apply the trigger. Trigger I am giving positive to 0. 90% of the students they go wrong. Positive to 0 it is, not negative. Positive to 0 applied. Op-amp 2 becomes high and output goes to high. Flip-flop output goes to low. Please observe. Hey, see here. Try to understand. I am saying this is high and because of that This is low, and because of that output is high. I am telling this much. Now because of that timer output is high. And what about transistor? Transistor is on or off now? Can you type? Transistor is on or off? Do it fast. Transistor is on or off. I have mentioned already, flip-flop or latch output is a low. Automatically I can say transistor is off. Very good for the answer. Now when the transistor is off, whether capacitor discharges or charges? Transistor is off, capacitor charges or discharges? Transistor is off, capacitor charges or discharges? Whenever the transistor is on, it will discharge. Whenever the transistor is off, it won't get the option to discharge. It will charge. See here, that's why I was asking this question to you. This is off now. Off बोले तो discharge करने के लिए option ही नहीं है उसको. So therefore, what it will do? It will start charging. Q1 is off. So therefore, C starts charging through resistor. Observe carefully. Try to understand. This is very important. See here, because Q1 is off, it is like open circuit. How C1 will discharge? Open circuit hoto. So it has a path. It will start charging. Observe this carefully. Try to understand. Because Q1 is off. Observe this. I'll give another 30 seconds. Try to understand this. Try to understand again, I am telling you. So I am talking about this. I have applied the trigger. When trigger, observe the red color in the waveform also. And output of the comparator 2 will become high. Because of that, latch will become low or high? Low. And output becomes high, and transistor becomes off. When transistor becomes off, Q1 is like a open circuit. Then capacitor starts charging through R1. Very simple steps. Very simple steps. Try to understand. Let me go to the next. Now, it has reached up to this state. Say, if VC becomes less than 2/3 VCs, op-amp 1 will give the high. That time, this is high. When this is high, output of the flip-flop will become high. Timer output will become opposite of this. It is a low. And Q1 conducts. When Q1 conducts, it gets a path, capacitor. Now it will discharges. This is on. So therefore, observe carefully. Hey, see here. C discharges suddenly. Why suddenly? Because there is no R. Observe carefully. There is no resistor. Therefore, it discharges very fast. Earlier, it was taking time because another resistor was there for discharging. So this is discharging very fast. So now I'll give the time for you people to go through and try to understand. And it remains in 0 till one more trigger pulse is applied. And now the question is whether 0 is a stable state or 1 is a stable state. Because there is a monostable. Mono means one state is stable. That is either 0 or 1. Which one is stable? You try to think. It will remain in the 0 state unless you apply one more clock pulse. So now you should be able to say which is a stable state. Try to understand. Another question may come in your mind. Sir, if I give one more trigger pulse here only, before this particular time period, if I give not only 1 or 2, there is no impact. That only we are going to show you in the next slide. Sir, if I give the additional trigger pulse, it is not going to impact on the operation of this monostable 555 timer in monostable mode. Unless it reaches 2/3, even if you give additional clock pulse, that will not impact this. One line you have to remember and you have to understand. And I told 1.1 RC, that is a derivation is there. How actually you will get a 1.1 RC? This derivation is there, and please try to go through this, and I think time is almost over. Another 1 minute I will take, and I will try to conclude today's class. Go through this derivation. So let us conclude today's class, and you may be having another class. 2-3 minutes you can take a time to log in to that class, and you can join that class. Thank you for attending today's class, and if you have any doubts you can discuss with your classmates or representative. Again, still if you need a discussion with me, we'll have a separate Google Meet for that. Have a good day, take care, be safe. Thank you. I'll be here for another 5 minutes. You can have a discussion with me if you have any doubts. Thank you.